1.3 is continuation of surface area. We're going to start by linking some ideas. So surface area, again, is the sum of all of the areas of all of the faces of an object. And there's another perspective that you can take to calculate the surface area for a rectangular prism or a cylinder. And that formula that you can use works the same for both shapes. So surface area is 2 times the area of the base of the shape, and then you add on the perimeter of the base shape times height. So let's see how that works for the 2 shapes. So for a rectangular prism, 2 times the area of the base. Well, your base in this case is a 4 by 2 rectangle, so the area of that is 4 times 2. And then you're adding the perimeter. Well, perimeter is 2 plus 4 plus 2 plus 4. So that's shown here. And then the height of this one happens to be 1. So then let's clean that up a little. 4 times 2 is 8. 4 plus 2 plus 4 plus 2 is 12. And then the 1 stays the same. So it reduces down to this a little bit. Then using bed mass, or the order of operations, you do your multiplication first. So 2 times 8 is 16. 12 times 1 is 12. Add those together and you end up with 28 centimeters squared. So that's one approach that you can do on that. You could say, okay, well, this is a 2 by 1, so that's 2, and it's got a matching one on the back. And this one is 4 by 1, and it's got a matching one. And then you get the top and bottom, which are 2 by 4. You can do all that, you'll come up with the same answer. So this is a bit of a slick approach to it. But you can use the same concept with a cylinder. Area of your base is a circle in this case. So the area of a circle is pi times r squared. And you multiply that by 2 based on this idea. And then to that you're adding the perimeter of the base. Well, perimeter of a circle is just your circumference, which when you're using radius is 2 pi r. And then you're multiplying that by the height, which is the height of your cylinder. So when you get rid of some of these multiplications and brackets and whatnot, the surface area can be calculated using 2 pi r squared plus 2 pi r h. Now we don't have numbers for this particular one like we did up here, but that's a quick and easy way to figure it out. If you know your radius and your height, you can calculate it fairly quickly. Now, let's look at an example here. Working example 1, calculating surface area of a solid. And in this case, all of the angles in the solid are right angles. So everything is square inside this. It looks like we've got a rectangular prism, and then there's a chunk taken out of the corner of it. It's a smaller rectangular prism has been removed from it. If you look down on it, you're going to see this shape here, and this area here has been removed. If you look at it from the front, this section has been removed. And if you look at it from this particular side, this piece has been removed. So, first question here, what are the dimensions of the cutout piece? So we've got the different views drawn so we can see what the angles are, or what the distances are. And you could actually draw this rectangular prism, and it's going to be 8 by 8 here on the short end, and then the length of it is 16 centimeters. So your dimensions are 8 centimeters by 8 centimeters by 16 centimeters. Let's turn the page and reassess. All right, so we've got this huge chart in order to try and work through the surface area of this shape. And what's been done is each individual piece has been numbered. So we've got 1, 2, 3, 4, 5, 6. 7 is the back wall that we can't see in this image. 8 is the right side back wall that we can't see. And then surface number 9 is the bottom of it. And with this chart, we're taking a look at each face individually. So like we did previously, drawing each particular face of our prism, you can do that with the more complex shapes as well. So for view 1, it's a rectangle with a corner cut out of it. And you can identify the different lengths here. So the area of this funky shape is the area of the whole rectangle minus the piece that's cut out. So the whole rectangle is equal to 15 times 20. And then we can subtract this 8 by 8 piece. So we've got 15 times 20 is 300, 8 by 8, or 8 times 8 is 64. Subtract that 64 from 300. And the area of the shaded region here for face number 1 is 236 centimeters squared. So that's 1 of 9 faces dealt with. Face 2 is the top. It has kind of a similar shape. It's a rectangle with a chunk taken out of it. 24 by 20 is the big piece. So that's 480 centimeters squared. The piece that's missing, 8 times 16, is 128 centimeters squared. And when you subtract that 128 from the 480, you're left with 352 centimeters squared. So we just need to work through face by face until we get everything done, and then we can look at the big picture again and put it all together. So 3 and 5 happen to be the same shape and size. So they are 8 by 16s, so they are 128 centimeters squared, each of them. Face 4 was a little square, 8 centimeters on both sides, so that has an area of 64 centimeters squared. 6 again is a rectangle with a piece out of it, and in this case it's 15 by 24, which is 360 centimeters squared. And then the piece that's missing is again 8 by 16, which is another 128 centimeters squared. So when you subtract the 128 from the 360, you end up with 232 centimeters squared for the shade area. 7 is the back wall, which is just a rectangle, 15 by 24. So that is 360 centimeters squared. Shape 8 was a rectangle on the back right side, which was 15 by 20. So that's 300 centimeters squared. And then lastly, the very bottom of the shape is a rectangle that's 20 by 24. So it's 480 centimeters squared. So we've now calculated all the different possible shapes that make up the outside of this solid. And if you add these all up, you're going to end up with 2,280 centimeters squared. It's a lot of work. Organizing in a chart like this is good when you're dealing with a complex shape like this. However, there's another technique that makes it a little bit easier to deal with. Let's have a look at that. Right, as we said, it was 2280 for the surface area. Let's have a look at method number 2. It is a little bit simpler. We're using symmetry now to be our friend. So if you look at the original shape with all the faces numbered, you'll notice that face number 2 plus face number 5 equals the entire top or bottom of the shape. So it matches face number 9. Face 1 plus face 4 is the same as face 8 for area. Face 6 on the frontish surface here plus 3 is the same as face number 7. So you can calculate the area of faces 9, 8, and 7, which are simple rectangles. So let's do that. Face 9, the bottom was 20 by 24, so it's 480. 8 was that back right side, 15 by 20, so that's 300. These are centimeters squared. And 7 was the back side, which was 15 by 24, so it was 360 centimeters squared. So if you add up those three, 480, and 300, and 360, you end up with 1140 centimeters squared. So you've got those three done. By symmetry, we know that all these other faces match them. So we can multiply it by 2. And when we do that, we end up with 2280. Which is the same answer we came up with before, but we didn't have to do all the fancy work. So the total surface area is 2280 centimeters squared. So here's a little factoid for you. Did you know? If you cut a right rectangular piece out of one corner, corner is an important word here, of a rectangular prism, the surface area does not change. So figure 1 is a rectangular prism. It has the same surface area as the one in figure 2, even though it's got a piece taken out of it. But it has to be a corner. The surface area does change if the cutout goes across the solid. So this one here shows more than just a corner of it. The whole piece is removed. So that does change the surface area, but this does not. So that's good to know. All right. You've got a big show you know to do here. It's looks like a little bit of a step. Rectangular prism with a full piece taken out of it. Go through the process and see what you can do.